Okay, lesson 3 for Calc, derivatives of logarithmic functions. And there's a couple different rules we have to learn here. This lesson's going to get a bit harder than the last one. But they shouldn't be too bad. There's a bunch of proofs and stuff. You can kind of just jump to memorizing the rules, though, for some of the places. First, we can actually prove what the derivative's going to be. If we have y is equal to ln of x, we can find what the derivative is going to be by changing form. So we change that back into e, which is base e, to the power y equals x. And then we take the derivative of this, which is the derivative of the whole thing, which is itself, times the derivative of the top, because we treat the top like it's its own function, equals 1. So that's not too bad. And then you move the e to the y to the other side, 1 over e to the y, and then you replace y with the original function. So now it's e to the ln of x, and e to the ln cancels out, so it just becomes 1 over x, and there becomes our first and most important rule of this one. So in general, the derivative of any ln of x is just 1 over x. Okay, and then we can see how that works with things like the product rule and the chain rule. So chain rule this time. So this is going to be y prime is 1 over the inside times the derivative of the inside, which is just 3x squared. And that's it for that one. So all you have to do is, then you simplify it a little bit, just do the whole outside derivative and then multiply it by the inside derivative. And in general, we can actually kind of summarize this. This happens a lot, the chain rule one. So people actually kind of memorize this, even though it's usually a fairly simple chain rule. They say if it's the derivative of ln of a function of x, it ends up being the function goes on the bottom, and the derivative of the function ends up going on the top. And that's what we have right there. That's the original function. That's the derivative of its function. And that's not too hard to memorize. I think I might skip some of these. This one right here is a pretty simple product rule. So you're going to treat that like x to the negative 1, and you're just going to take the derivative of the whole thing. So the derivative of the front, which is negative 1 over x squared, times ln of x, plus 1 over x times 1 over x, which is 1 over x squared. Then there ends up being a common denominator, and so you just combine them together into that. So that one's not too bad. That's just chain rule. Sorry, product rule. This guy here, this is a chain rule with the ln on the inside this time. So we could actually do this really kind of quick. It's just going to be derivative of the outside, which is 4 times ln of x cubed, plus the derivative of the inside. Sorry, times chain rule. Times derivative of the inside, which is 1 over x. And that should get you right to this answer right away once you combine those terms. Okay, this guy's much harder though. Or a fair bit harder, at least we should say. So what's going on here? We have the ln of a function, so we're going to be using this kind of a thing. It's going to be the chain rule, where the original function goes on the bottom, and the derivative of that function goes on the top. So if we wanted to be nice and thorough, maybe we want to take the derivative of this separately. This is something we haven't been doing a lot of, and it actually can be very useful. So let's treat u as x plus 1 times root of x minus 2 to the negative 1. And then u prime is going to be, we can do this one separately. And then all this can end up going on the top after. So this is actually the hard part. Okay, so derivative of the first, which is just 1, times the second, plus derivative of the second, which is going to be negative 1, times root, I should have done this as 1/2. Let me start this over. So that's negative a half. There. Now that's a bit better. So u prime is equal to the second, because the first is nothing. Derivative of the first times the second, which is x minus 2 to the negative a half, plus the second, derivative of the second, so plus a negative 1/2 to the x minus 2 to the negative 3/2 times the first. Okay, tidying this up, so we're going to common factor x minus 2 to the 3/2. That leaves an x minus 2. That leaves a 1/2 minus 1/2 x plus 1. Okay, and what they did at this point, they do this in, I don't know where they did this, but they actually also common factored a half. And we should try and remember we like to clear our fractions as well. So I'm going to do that as well. I'm going to pull out just the positive a half, because we like the first term to be positive, usually. So I'm going to pull out a half to go with the x minus 2 to the negative 3/2. And that's going to leave, so this half disappears, and this one becomes twice as big. So it's going to be 2x minus 4 minus x, now I can rainbow that in, minus 1. Okay, and then tidying it up, this joins it on the bottom. So on the bottom I have 2x minus 2 to the 3/2. And on the top I have x minus 5. Good. That would probably be a nightmare to do all in the same line, as it's kind of good to do it separately. So now all we need to do is treat this as a chain rule. So y prime is equal to derivative of the outside, which is 1 over this thing. And that's the same as saying this thing to the power of negative 1, which actually just flips these terms upside down when it's a fraction. So it becomes x minus 2 all over x plus 1. That's the ln part times the derivative of the inside, which we have down here, which is x minus 5 all over 2 x minus 2 to the power of 3/2. Okay. And then we need to look at this and say, before we smush it together, can we cancel? This is an x minus 2 to a half, and that's 3/2. So I can actually get rid of a half one off of here. So that cancels with that. And that leaves how much if I'm subtracting a half? So it's a half subtract 3/2, which becomes negative 2. So it becomes an x. Wait, did I do that wrong? 1/2 subtract 3/2 is equal to negative 2 over 2. So actually just negative 1. So there's 1x minus 2 left on the bottom after that. And that lowers this one by kind of adding to it in reverse. It's weird. Ends up being just that. And then there's the x plus 1. And then on the top there's an x minus 5. And there's a 2 still. And that's it. This one's hard, but this is all just previous knowledge. That's the hard part. Applying it with the 1 over x, the only tricky thing was you have to flip these. So instead of saying it's 1 over x plus 1 over root x minus 2, just flip these things upside down. That's also what ln does. Okay. Couple new proofs. We've been talking all about ln of x and e to the x, but what happens if we have values of a? So what happens if the base is not e or ln? We have, these rules aren't too hard. There are proofs of them. I don't know if I want to go through the proofs. maybe, do I want to do them? Maybe I'll do one of them for you. I'll do the first one. Okay, proof of this guy. So we can find what the derivative of y equals a to the x is. And all we have to do for that is, there's actually one really important rule in this one, is you have to remember that a to the x sorry, they use the fact that ln e to the ln of a to the x of a is equal to a. That's the important rule that they use. Sorry, I'm just looking at the textbook. I just did this on my own, but it's easy to forget the proofs. So we're going to use this fact that these two things cancel to get to that. And the first thing we're going to do is, so we're going to take dy by dx of a to the x. We're trying to find this, and now we need to change it. We need to manipulate it to be in terms of e. So the very first thing we do is raise it to the power. We kind of apply this rule. So we say it's the exact same thing as e to the ln of a to the power x. D by dx. D by dx. I should have wrote that in there. We haven't taken the derivative yet. That's actually important to write down. So I'm just manipulating it so it's in terms of e. And then we can actually bring the x in because multiplying exponents. So we still have to take the derivative, but it now looks like e to the ln of a times x. Now that's not too bad. Now we can actually take the derivative because we have derivative rules for e. So the derivative of this thing is going to be the derivative of the whole thing, and there's an x as a power, so it ends up just being itself, e to the ln a x. We've taken the derivative now, but you have to multiply it by the derivative of the top. Okay. Now the derivative of the top, ln of a is just a number, so it's a coefficient, so we can ignore that. If we're taking this derivative with respect to x, there's actually just a single x term, so it turns into 1. So this whole thing just becomes ln a. So it's equal to e ln a x times ln of a. And then we can use that rule again to say these two things cancel out. E to the ln of a is the same thing as a. So that's a to the x times ln of a. Good, and that's where we get our rule. So that's rule number one. If you have an exponent, this is going back to our last unit. If instead of e to the x, if you have a to the x, the derivative is itself, but you have to times it by the ln of a. It's like a change of base derivative kind of rule. And then we have the same kind of rule down here. What happens if we don't have ln of x? What do we do this time? So if we have log of some other base, not e, what you do is very similar. You do 1 over the ln of that, 1 over x, like it were the ln 1, but then you have to times it by the ln of the base. So both times, it's the original derivative rule times the ln of the base. Ln of the base there. This time the ln of the base comes with it on the bottom though. So that's the only two special things. If you have a base that's not e or ln, then it's the original derivative rule times the ln of the new base, either on the top or the bottom. Okay, so let's try out if that works. So this is a chain rule one. We have the log rule, and then we're going to do derivative of the inside. So first, derivative of the outside. So log of 5 of this thing, we know now is 1 over the inside, which is t to the 4 minus t squared plus 1. That's just our ln rule, and then our new rule for the change of base is times the ln of 5 on the bottom. That's all we have to do. And then we need to do the chain rule, so we need to times that by the derivative of the inside, which is just 4t cubed minus 2t, and that's it. And then we'd simplify that down. Y prime is equal to 4t cubed minus 2t all over. Ln of 5 is kind of a coefficient. I would move it to the front. Really, we'd probably want to factor this one, but there's going to be nothing to cancel with it, so we can't really go any further. That's it for that. So kind of 3 important rules. We have our new ln rule, which is fairly easy to manage, just like the e to the x rule. And then we have 2 new rules for if the base is not e. If the base is some other number, then you use the same rules, but you multiply it by the ln of that number. Okay, this is going to take some practice, so try lots of these. You're going to have, Wednesday in class to go over these questions, and then we'll do a quiz on this on Thursday. Good luck.